Hey everyone, it's Dr. Walker. Let's look at the first example from video 53C on the center of mass. This problem is asking us to find the center of mass of this system. The system consists of the three masses. We can see that M1 and M2 have a mass of 1 kilogram and M3 has a mass of 2 kilograms. We can also see the position of each mass. We're looking for the position of the center of mass. We can approximate that it would be at the position shown here. This is just an approximation. We know that we have some mass on one side, some mass on the other. It's going to be somewhere near the center. Not exactly in the center though, because of the position of each mass. Whenever we have masses like this, we treat them as particles, and we use our definition of center of mass for particles. It's easier to look at the x and y coordinates separately and then put them together to find our position vector. So let's find the x coordinate of the center of mass using our definition. 1 over m times the summation of all of the m's times their x's. We have 3 particles, so we just have to add this 3 times. M1 x1 plus M2 x2 plus M3 x3 all over the total mass, which is M1 plus M2 plus M3. So that's how we use this equation. And now we just have a lot of plug and chug here. We're going to plug in the masses, so 1, and then the x coordinate of this position. So M1 is at 1 meter, M2 is at 2 meters, and M3 is at 0 meters. So 1 times 1 plus 1 times 2 plus 0, right? The position, the x coordinate is 0 for x3. And then we divide by the total mass, which is 1 plus 1 plus 2. Even though the term cancels out for the position, that does not mean that you cancel out M3. You still have to do the total mass, even if their position is equal to 0. We add up all of this, it gives us 0.75 meters. Now we do the same thing for the y-coordinate. The y-coordinate is a lot easier because we can see that M1 and M2 have a 0 y-coordinate, but let's still write the equation, the y center of mass coordinate, and we can just go directly to this kind of expression equals M1 y1 plus M2 y2 plus M3 y3 over the sum of all of the masses, M1 plus M2 plus M3. It says the position of M1 and M2 is 0 for the y position. We can cross out the whole term. And then all we have left is M3 y3, so 2 times 2 divided by the sum of all the masses, 1 plus 1 plus 2. So that gives us 4 over 4, which is 1 meter. So once we have the x, y, and z coordinates, in this case the z coordinate is going to be 0, when we have those coordinates, we can go ahead and write our position vector, r, center of mass. All we have to do is put the x center of mass coordinate in the I direction plus the y coordinate in the j direction. That was our expression. So it's going to be 0.75 in the I plus 1 in the j, and we can specify that this is indeed in meters. So we can see that that is where the position is. Kind of in the center, but not exactly.